All right, so we're about to start chapter 2, which is called Limits to Measurement. And during this chapter, we are going to use these ideas to explore the concept of measurement accuracy, to examine the concept of measurement precision, to distinguish the difference between accuracy and precision, to calculate measurement uncertainty, and to examine acceptable tolerances in various workplaces. Now, before we start that, we do need to review a few things that will be important to this chapter. The first of those things is cross-multiplying. So remember that when you're cross-multiplying, you multiply for the number across from it. So you'll get 21 times 3, which is 63, equals to 17x. Then we divide both sides by 17 and get x to equal about 3.7. Okay, so the next one, try it on your own first, and then you could follow along. So again, we multiply across, so we're going to get 12x equals 3 times 18, which is 54. Divide both sides by 12 to get x by itself. So x ends up being equal to 4.5. Now in this course, many things can be calculated using cross multiplication, and it's probably one of the easiest ways to calculate things in this measurement chapter because everybody does know how to cross multiply. So try to use it as often as possible. So there are two different measurement systems that are used in Canada. We have the SI system, which is the new name for the metric system. And the base units for this system are meters, grams, and liters. So we have meters with a small m, grams with a small g, and liters with a capital L. Then there's the prefixes to each one of these that determines how big or how small the unit is. So kilo is 1,000 units. And remember, your base unit would be right here in the middle. A hecameter would be 100 units. A decameter would be 10 units. The base unit is, again, meters, grams, or liters. Deci is 10 decis would go into 1 unit. 100 centis would go into 1 unit, and 1,000 millimeters would go into 1 unit. So that is our metric system. Now, when we're working with this, if you're going from a big number to a smaller number, you're going to multiply. But if you're going from a smaller number to a bigger number, you divide. Okay, so that's basically how you can figure out all of these conversions. Okay, so convert the following and round to the nearest tenth of a unit. So we're starting with meters and going to kilometers. So if you look back to our little diagram here, we're starting at the base unit and going up to kilometers. So since we're going up, we need to divide. From base unit to kilometers is 1,000 units. So we need to divide by 1,000, which would give us 0.065 kilometers. Now we're rounding it off to the nearest tenth of a unit. So what would we round that off to? No, to the nearest tenth. So 0.1, because the tenth would be the first digit after the decimal place. So then meters to centimeters. Again, I'm going to look back to our chart. We're going from the base unit here down to centimeters. So we need to times by 100 because there's 100 centimeters in a meter. So we're going to times by 100, which gives us 4,500 centimeters. And again, round it off. It's already rounded, so we can put the same amount there. Try the next two on your own and then check your answers with mine on the board when you're finished. So in class here, we had one good point where you can actually use cross multiplication to do all of these as well. So let's say we take the number 65 and we have 65 meters. And we're trying to figure out how many kilometers that is. We can set that equal to one of our equality relationships from the slide before. So we know that 1 kilometer is 1,000 meters. And we can go back and put that in. So there's 1,000 meters is the same as 1 kilometer. Now, remember that when you're doing this, you want all of your same units on the top as the same units on the bottom. So meters are on top, kilometers are on bottom. You can go ahead and cross multiply. So we're going to get 65 equals 1000x. Divide both sides by 1000. And we'll get x equals 0.065, just as we did before. So that also works. Now the next thing is the imperial system. This is used most often in the US, and it often involves converting fractions, which I know everybody loves. Yay! Most common units in this course are the feet, inches, yards, and miles. So that's just what we're going to talk about today. 1 foot is 12 inches, so that would be your conversion factor. 1 yard is 3 feet, or you could put 36 inches. And then 1 mile is 1,760 yards. So let's try some of these. If you have a half a foot plus a half a foot, and we want to figure out how many inches that is, the first thing we need to do is add the fractions. So if we go 1/2 plus 1/2, what does that give us? 1/2 plus 1/2 would be 2/2, which is the same as 1. So we have 1 foot, and we want to convert that to inches. So 1 foot is x inches, and we can set that equal to, we know that there's 12 inches in 1 foot, and cross multiply to get x equals 12 inches. So 12 would go in there. Now the next one, remember that when you're adding or subtracting, you need a common denominator. Good. So to find a common denominator, let's say we have 1/8 plus 1/4. The common denominator will be the bigger number that the two go into. So both of these numbers go into 8. So we can multiply the second one by 2/2 to get 1/8 plus 2/8, which is 3/8 as our factor. Now we want to figure out how many inches that is. So we're going to, that's 3/8 yards. We want to figure out x inches. So again, we set that equal to, there's 36 inches in 1 yard. Cross multiply and get x equals to 13.5 inches. All right, go ahead and try the rest on your own. Okay, so once you're done, you should have these answers. Now just be careful with this last one. If you have 9 1/4 and you need to convert it into an improper fraction, remember that you multiply the bottom number times the number out in front, so you'd get 36, and then add the top number. So you'd end up with 37/4, subtract 15/2. Then you can go ahead and find a common denominator and subtract the two fractions. You notice that both of these are in inches, so we don't actually have to change anything. Scale factor is next. So scale factor, we know that these two things are similar to each other. So whenever it says that something is similar, you can set it up in a cross multiplication ratio. So first I'll draw a picture. I have a width of 5.25 on the one table with a length of 7.25, and then a little bigger table with the width is unknown, but the length is 9.06 feet. So now I want to set this up as a ratio in order to cross multiply. So I'm going to put my widths on the top and the lengths on the bottom. So I start with 5.25 over 7.25. I'm going to set that equal to my unknown width over 9.06. Now notice that these are the widths and these are the lengths. Also that this whole part would be table 1 and this whole part would be table 2. Then you can just go ahead and cross multiply, and your answer should end up being x equals 6.56 feet. So unit price is also very similar. Unit price can always be set up as a cross multiplication ratio as well. So here we have 8 apples that cost $5.20. Let's put the apples on top and the money amount on the bottom. So we have 8 apples is $5.20. We want to figure out how much it costs for 1 apple. So again, on top we have apples, and then on the bottom we have cost. You can go ahead then and cross multiply, and you'll find that X equals about $1.54 for one apple. So that would be your unit cost. So now you can go ahead and start your assignment, which is the handout. It's actually on the Moodle as a, I think it's as a PDF right underneath this assignment or this smart handout. All right, that's it for today. There will be another lesson tomorrow. So it was pointed out that I actually made a mistake in this problem. Sorry about that. It's supposed to be x times 8 is 8x equals 1 times the 520, which is 520. Divide both sides by 8, and x should equal $0.65. That should be your final answer. Sorry if that confused you.